If you think system design is a topic you only worry about as a senior developer, you're setting yourself up for failure. The concepts we're about to cover dictate exactly what happens to your code in the real world. They determine whether your application can smoothly handle 1 million active users or if it immediately crashes under the pressure. Look at this trajectory. This is the developer's ultimate nightmare. Your app goes viral, and your user base spikes from 10 people to 1 million overnight. Without the right architecture, that sudden success destroys your system. To survive that kind of massive growth, we are going to build an enterprise-grade architecture from the ground up, step by step. Proactive system design is the only way to ensure that an explosive influx of users becomes your biggest victory rather than a fatal flaw. The first bottleneck of growth always hits at the server level. You start with a single machine handling all of your incoming requests, and as traffic multiplies, that server is quickly overwhelmed. This diagram outlines your two options for scalability. On the left is vertical scaling, where you add more CPU and RAM to that one struggling server. On the right is horizontal scaling, where you deploy an army of smaller, identical servers to share the load. Massive platforms like Instagram do not rely on one massive supercomputer. They stay online by distributing their workload across thousands of horizontally scaled servers. An army of servers introduces a new problem. Unpredictable requests might violently flood a single machine, crashing it while others sit empty. To fix this, we introduce a load balancer, an efficient traffic director that evenly distributes incoming requests. Raw computing power is ineffective if your system lacks the intelligence to evenly divide the workload. Now, our load-balanced servers are functioning perfectly, but we hit our third bottleneck. Every time a user requests something, the server has to fetch it from the main database. That constant travel time causes severe slowdowns. We solve this with caching. This animation shows the difference in retrieval speed. Instead of making a slow trip to a distant database every single time, we store frequently requested data in a temporary, ultra-fast memory layer right next to the server. You experience this daily. When you open a YouTube video for the second time, it loads instantly because your device pulls it from a cache instead of fetching it from scratch. By intentionally reducing the distance data has to travel, you remove the friction of constant retrieval, decrease the strain on your database, and guarantee a fast user experience. Even with fast caching, this core database cylinder has grown too massive to process queries. It's buckling under its weight. The solution is database sharding, strategically fracturing it into smaller, efficient shards, then distributing user data alphabetically across them. Instead of forcing your system to scan one overloaded monolith for every query, you are now searching multiple small, specialized databases simultaneously. To sustain growth as your data reaches petabyte scale, your core storage must be decentralized. You have to eliminate the database as a single point of failure. We now reach the final and often most overlooked bottleneck. Our infrastructure is perfectly scaled, but the application code is still one massive intertwined block. In a monolithic codebase, every function is connected. That means a single bug in a minor feature, like a faulty comment section, can trigger a chain reaction that crashes your entire application. We prevent this total collapse using a microservices architecture. As shown here, we break the application code down into completely independent, self-contained functional services. Instead of one giant app, you deploy distinct login, payment, and notification services communicating via APIs. This brings a massive advantage. If a service fails, the damage stops locally. Your core app runs seamlessly. Resilience comes from isolating failures locally so they cannot spread globally. We have systematically evolved a fragile single-server application into a fast, balanced, and durable system. It relies on 5 foundational layers acting as one cohesive unit: scalability, load balancing, caching, sharding, and microservices. This requires moving beyond the logic of individual functions to consider how these components interact across a network. If you want to dive deeper into this blueprint, check the description below for detailed system design notes and real-world interview questions. And make sure to subscribe for more content that sharpens your engineering skills. Understanding how these 5 layers interact is a fundamental step toward building the infrastructure that powers the modern web.